Fats and oil introduction. These are the heterogeneous group of organic compounds but placed in on these are the heterogeneous group of organic compounds but placed in one class on the basis of their common functions. These are the main constituent of plant and animal tissue soluble in organic solvent such as ether, chloroform, benzene, and carbon tetrachloride, and insoluble in water. In recent years, the role of lipid in diet has received attention because of their apparent connection between saturated fats and the blood cholesterol associated with arterial disease. Lipids like fat and oils are important raw materials in industry like soap, vanaspati ghee, plant and the varnish industries, etc. The name lipid originates from the Greek word lipos for fat, biological function. Lipids are biologically important compounds and play following function. These are the main components of cell membrane and therefore associated with transportation across cellular membranes. Second, they provide insulation for the vital organs, protecting them from the mechanical shock and in maintaining optimum body temperature also. Third one, these are the important energy storage compounds. The food taken above normal requirement of the animal is converted into fat as reserve product in the form of fat body. Fourth one, glycolipids and the lipoproteins are essential for maintaining cellular integrity. Fifth one, the compound lipid like phosphatides of blood platelets are associated in the production of the thromboplastin which is essential in the primary stage of the blood clotting. Sixth, some vitamins A and D and hormones, example steroids, necessary for the proper functioning of our body are lipids. Lipids like waxes from protective covering in plants. Classification. These are classified on the basis of their hydrolysis product and also according to their similarities in molecular structure. First one, simple lipids. Simple lipids a part fats and the oils. These give fatty acid and the glycerol on hydrolysis. These will be discussed in the detail in next section. Oil and the liquids at ordinary temperature and contain large proportion of unsaturated fatty acid unit where fats are solid glycerides of the saturated fatty acid. Lipids obtained from the animal origin are generally fats, for example butter, beef tallow, etc., whereas those obtained from the vegetable origin are oils, for example cotton oil, groundnut oil, linseed, corn oil, coconut oil, etc. B part, waxes. These are the esters of the fatty acids and the long chain alcohols. These give fatty acids and the long chain alcohol on hydrolysis. These provide protective coatings on the surface of the plants. These coatings protect plants from the infection, adhesive damage, and loss of the water on transpiration. For example, bee wax, myricil palmitate, Camboavex serpemaceti. These are used for making cosmetics, ointment, polishes, and other pharmaceutical products. Second one, compound lipids. A part, phospholipids or phosphatides. These give fatty acids, glycerol, phosphoric acid, and a nitrogen containing alcohol on hydrolysis. For example, alpha lecithin give phosphatide serine and further cephalins. Fatty acids most commonly found in lecithins are palmitic, stearic, oleic, linoleic, arachidonic acids, whereas cephalinids usually contain stearic, oleic, linoleic, arachidonic acids. Brain and nerve tissue are rich in phospholipids. Phosphatides are often found associated with proteins and the glycolipids. B part, sphingolipids. These give fatty acids, phosphoric acid, sphingosine, and an alcohol component on hydrolysis. The sphingolipids with proteins and the polysaccharides make up myelin, a protective coating that encloses nerve fibers or the axons. The axons of the nerve cell carry electrical nerve impulses. For example, sphingomyelin. C part glycolipids. These produce fatty acids, sphingosine or glycerol, and a carbohydrate on hydrolysis. For example, a glycolipid found in brain tissue is named as ganglioside. The cerebroside shown below in an example of the glycolipid. Steroids. These are the main compounds containing a cyclopentophenanthrene structure and are quite different from the lipids made of fatty acids. These mainly act as hormone. Fats and oils. Oils and fats are mostly triglycerides. These triglycerides are triesters of the three long chain fatty acids C12 to C22 with glycerol, a trihydroxy alcohol. These may be believed to form in the following manner. Fatty acid react with the alcohol, that is glycerol, in the presence of the catalyst give triglyceride and 3 moles of H2O. When all the three hydroxyl groups are esterified with the same fatty acid, the resulting ester is known as simple triglyceride. However, naturally occurring fats and oil containing 2 or 3 different fatty acid components are called mixed triglycerides. For example, glyceryl stearate, glyceryl oleate. These triglycerides are further classified on the basis of the physical state at room temperature. It is called fat if solid at 25 degrees Celsius, whereas oil if liquid at the same temperature. It is found that fats contain a greater proportion of the saturated fatty acids, whereas oils contain a greater percentage of unsaturated fatty acids. For example, glyceryl tristearate having saturated acid moiety is a fat. Solid melting point 71 degrees Celsius, whereas the trinolene having unsaturated acid moiety is an oil, liquid at room temperature, melting point 9 degrees Celsius. Mixed triglycerides containing both saturated and the unsaturated acids have intermediate physical consistency. Oil and the fats are generally mixed triglycerides. Oil contains more of short chain saturated acid residues and unsaturated acid residues, whereas fats contain more of the long chain saturated acid residues. These acids associated with the glycerides of the oil and the fats are generally straight chain acids C4 to C20 containing an even number of the carbon atoms. The unsaturated acids associated with the natural glycerides may contain one or more carbon-carbon double bond. The major acids associated with oils and the fats are palmitic, stearic and the oleic acid. Common fatty acid present in fats and the oils. Fats and oils commonly used in food are obtained from the animal fats like butter, fat, beef, tallow, lard, etc. and vegetable oils like groundnut oil, coconut oil, soybean oil, sunflower oil, sesame oil, linseed oil, etc. Oil and fats are complex mixture of triglycerides. Butterfat, for example, contain glycerides derived from over 100 carboxylic acid. Table lists the fatty acids composition of vegetable oil and the animal fats with their analytical constants. Acid value. It is defined as the number of milligram of the potassium hydroxide required to neutralize the free carboxylic acid present in 1 gram of fat or oil. The acid value is determined by dissolving away quantity of the fat or oil in neutral alcohol and titrating against standardized potassium hydroxide solution using phenolphthalein as indicator. The acid value give an idea about the amount of free acid present in a particular oil or fat. A high acid value indicates acetate or rancid fat or oil stored under improper conditions. Low or negligible acid value indicate non-rancid fat or oil. Sponification value. The alkaline hydrolysis fats and oil is called sponification because one of the product of hydrolysis is soap. The hydrolysis provides a method the hydrolysis provides a method for the determination of the constant called sponification number or value, which is defined as the number of milligrams of potassium hydroxide required to sponify 1 gram of the fat or oil, that is to neutralize the fatty acids resulting from the complete hydrolysis of 1 gram of the fat or oil. For example, sponification values of the tellurate and the tristyrene can be calculated as follows. Sponification number is equals to 3 moles of the KOH into 1000 divided by 1 mole of the fat or oil. Sponification number is equals to 3 into moles of the KOH, that is the 168 into 1000 divided by 1 mole of the fat, that is the tellurate, whose molecular weight is 638, is equals to 263.3. So sponification number is equals to 1,68,000 divided by molecular weight of the fat. Similarly, for tristyrene having molecular weight 890, sponification value will be 189 mg/kOH per gram fat. Thus, sponification value of a fat gives an idea about its average molecular weight. The higher the molecular weight of the fat, the smaller is its sponification value. For example, tristyrene molecular weight 890 has sponification number 189, whereas low molecular weight tellurate molecular weight is 638 has sponification value is 263. It also indicates the length of the carbon chain present in the acid moiety of the oil or fat. The higher the saponification value, the greater the percentage of short chain acids in the glycerides of oil or fat. Experimentally, sponification value is determined by refluxing a weight amount 1 to 2 gram of the oil or the fat with non-excess of the standard alcoholic potash solution and back titrating the excess alkali with acid. Sponification value of some fats and oil are given. Fats: butter sponification value is 210 to 230, beef tallow 190 to 200, sardine 185 to 195. Oil: castor oil sponification value 180 to 190, olive oil 180 to 185, soybean oil 180 to 195, coconut oil 250 to 260. Iodine value: the degree of absorption of halogen by a fat or oil is proportional to the number of double bonds present in carbon chain of fatty acid moieties. Thus, this addition reaction is used as an index of the degree of unsaturation in fat or oil. The index value is called iodine value or number and is defined as the number of the grams of the iodine or its equivalent like iodine chloride that will add to the 100 grams of the fat or oil. A known weight of the oil or fat is dissolved in chloroform solution. Iodine chloride dissolved in acetic acid is then added. Iodine chloride adds across the carbon-carbon double bond. Excess iodine chloride is then treated with the potassium iodide solution to liberate equivalent amount of iodine, and this is back titrated against standardized hypo Na2S2O3 solution using starch as an indicator. Iodine chloride, or an equivalent amount of iodine that had added across the double bond, is determined, and the iodine value of the oil or fat can be calculated as iodine value is equals to V1 and the V2 into N into 12.7 divided by W. Here V1 is equals to volume of the hypo used for blank. V2 is equals to volume of hypo used by the unreacted iodine in back titration. N is equals to the normality of the hypo solution. W is equals to the weight of the sample oil or the fat. Thus, the greater the number of the double bonds in an oil or the fat, the greater is its iodine value. For example, iodine value of linseed oil highly unsaturated is equals to 170 to 185, peanut oil 87, corn oil 120, beef tallow relatively saturated fat 30 to 48, olive oil 82, cottonseed oil 109. Synthetic detergents, or the soapless soap as they are the sometimes called, are synthetic substances that are being increasingly employed as cleaning agent these days. Unlike soap, detergent can be used satisfactorily even in hard water since they don't form curd like precipitate in such water. Huge quantity of the different type of detergents which differ chemically from the soap as well as from another are now being manufactured and used all over the world. However, all these detergents are similar to the soap as in that their molecules also have a large non-polar hydrocarbon, and that is oil soluble, and an ionic, and that is water soluble. Typical synthetic detergents. Some synthetic detergents are described below. Sodium alkyl sulfate. These detergents consist of the sodium alkyl sulfates obtained from the long chain alcohols. The first such detergent was made from the 12 carbon straight chain alcohol 1-dodecanol. The alcohol was treated with concentrated sulfuric acid to form a sulfate ester, which when neutralized with sodium hydroxide formed a detergent known as the sodium dodecyl sulfate SDS, as shown below. Alkyl benzene sulfonates. The most commonly used detergent these days are the linear alkyl benzene sulfonates LAS, such as sodium dodecyl benzene sulfonate. These are obtained by the conversion of the benzene into alkyl benzene, followed by the sulfonation and the neutralization as shown below. Sodium alkyl sulfate and alkyl benzene sulfonate are also known as the anionic detergent because their cleaning action is due to the formation of the anions having long hydrocarbon chain attached to them. Cationic detergents. This detergent consists of the quaternary ammonium salts such as the chloride and the bromide containing one or more long chain alkyl groups. Two such detergents are the citrotrimethylammonium ammonium chloride, benzyl dimethyl octyl ammonium chloride. These detergents are called cationic detergents or invert soap because their cleaning action is due to the formation of the cation having one or more long alkyl groups and not due to the negative ion as in detergent described above. These detergents also have germicidal properties, but they are quite costly, therefore they are not used on large scale. Non-ionic detergents. Ethoxylates. These are the non-ionic detergents consisting of the long chain hydrocarbon chain plus repeating ethoxy units ending in an group. These are the obtained from the long chain aliphatic alcohols by treating with the ethylene oxide in the presence of the base. For example, even though these detergents are non-ionic, The presence of the numerous oxygen atom renders the polyether end of the molecule water soluble through the formation of the hydrogen bond. Thus, it serves the purpose of the polar end. The long hydrocarbon chain is, of course, insoluble in water but soluble in oil. Such detergents are particularly suitable for washing machines, dishwashers because they have low leather washing action.